Welcome to Tech Talks. Our platform edition today is focused on simplifying ticket remediation with machine learning. For those of you who aren't familiar, Tech Talks are a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. So our experts have helped to create these best practices, and we're hoping that you'll leverage them in your daily role. My name's Greg Ainsley-Malik. I'll be taking you through this tech talk today. I'm a principal product manager at Splunk, looking after the Machine Learning Toolkit, which of course I will be talking about as we go through this tech talk. And today we're going to be talking about a number of things. So first of all, we'll go through a brief introduction to machine learning at Splunk. We're then going to talk about the particular use case that we're focused on for this tech talk, which is ticket management. We're then going to show you a demo of what that actually looks like. And then we'll cover off some additional resources that are available to help you take advantage of machine learning capabilities at Splunk. The team is going to be available for Q&A throughout. So if you hover over the Q&A widget within your screen, you'll be able to talk to them. And if you're watching a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in the Splunk community at splunk.com/techtalk. So when we look at machine learning at Splunk, we've actually got it across pretty much our entire portfolio. And there's kind of three main areas that breaks down into. The first one, I mean, we've called it search here, but really I would look at this as the core Splunk platform, in that we do have a number of search commands, such as predict or X11 or anomaly detection that some of you might be familiar with, that actually utilize machine learning under the hood. These are things that come with the core platform, with Splunk Cloud. There's also a tab when you run a search called patterns, and that's actually a really good example of clustering that runs. So I'd encourage you to check that out if you haven't already. And as well as this core platform functionality, we have a whole host of apps that sit on top of that allow you to utilize some more advanced machine learning. Of course, the main one is the Machine Learning Toolkit, which not only provides a number of search commands that extend the core platform and allow you to train models, apply models, but also has a set of experiences, so assistants, experiments, showcases, that can help you familiarize yourself with machine learning without having to be experts. But as well as the Machine Learning Toolkit, there are a number of other apps. The DGA app for Splunk is a really good example of a pre-packaged workflow that utilizes machine learning so that you can detect malicious domain names on your own data. Another good example of an app is the Smart Ticket Insights app, which is the one we're going to be talking about in this tech talk today. Alongside these apps and platform capabilities, we of course have a number of premium applications like enterprise security or IT service intelligence that come with pre-packaged machine learning for specific use cases. So when we look at ES, for example, there are a number of detection searches in there that can help you find anomalies to discover particular threats. That could be in user behavior, that could be in network behavior. And in ITSI, there are also a number of ML enabled features such as clustering events to reduce noise or predicting potential outages. So a whole host of functionality across our platform. The bit we're going to focus on today, like I said, is the Smart Ticket Insights app for Splunk. And before we dive into what that looks like and what it gives you, I thought I'd first of all talk through why we worked on this in the first place and kind of what our thought process was behind designing the app. So one of the things, and I'm sure many of you listening will be familiar with this, to run a business, to run an organization can be complex, and keeping track of the work that is being done, who is working on it, what they're working on, usually necessitates some kind of ticketing system. And there's a whole host of great vendors out there, ServiceNow, Jira, BMC Remedy, the list goes on, that can help you kind of manage those operational tickets. I'm sure some of you have even done it with spreadsheets in the past. But there are a few key themes that come out of this, right? And one of those is that generally managing your operations means that you end up with quite a lot of tickets just to keep track of what's going on. In addition to this, those tickets can relate to pretty much any aspect of your business. So you could have some related to physical security, you could have some related to HR, you could have tickets that relate directly to customers and requests or even complaints that they've made. And a theme that we've seen with our customers is getting insight from that variety of ticket data can often be quite challenging. So really what we wanted to do is develop something that helped provide some insight into that ticket data. And there were three key things that we were hoping to help with in this. The very first one down at the bottom was just trying to provide some insight into tickets that occur often. So if there's any kind of recurring issue, how do we spot it? How do we understand that it's there? The second piece then kind of fed from that, which was, now that we have an idea into these recurring issues, how do we better manage them? Because really they're what I would term problems. So it feeds into the whole problem management cycle. And then finally, if you reach a level of maturity where you actually feel like you're getting good insight into the recurring issues, you feel like you've got a good handle on the problems that are occurring across your organization, can you actually automate the remediation of some of those issues? So that instead of someone having to manually triage a ticket every time it comes in, can we write some automation on top of that so that we can automatically triage it, put it into a pipeline, get it remediated without much human involvement? So that was the background. In terms of how we approached it, we actually looked across a range of internal data and also worked with a few customers on this to try and figure out what features are common across ticket data and how could we mine those features to try and gain some insight into our ticket data. And we came up with 4 features, 4 bits of information that were fairly consistent across all the ticket data that we saw. So the first one is, of course, a ticket ID, having some kind of identifier that allows you to track the activity that's associated with it. That was pretty prevalent. We also saw that category and subcategory were also 2 key bits of information that were usually associated with tickets. Although it's not on the slide here, we also saw with some customers that having like service owners was also another bit of information that was fairly consistent and actually really helped with problem management in particular. And then finally, the bit of information that's critical for the app that I'm going to take you through in a moment is description. So having something that we could mine for insight that contained more context and more details of what the ticket was actually about was really important. And just before I kind of move on to actually showing you what it looked like, it's worth saying that when we looked at things like category, subcategory, or service owner, often those bits of information weren't granular enough to help really identify the recurring problem. They were still quite large buckets, even at the subcategory level. So that description really was key. And the approach we took was to use a few natural language processing techniques to try and decompose it into key terms, and then clustering over those key terms to identify patterns that were occurring in our ticket data. And really it was those patterns that helped us find the recurring problems. Okay, so let's move on to the demo where I can actually show you what this looks like properly. Okay, so this is the app itself, and before I start working my way through the content, I thought I'd just show you the homepage, which kind of describes how the app is laid out. Effectively, there are 3 separate sections. The first one is to help you input some data, so run a search that queries the data that contains your ticket information. The second section is then to help create some smart groups on top of that data. And then finally, there's a section that allows you to manage those smart groups once you've trained them. So if we get started with the data input, I've already pre-filled the search here. What I'm actually doing is querying some Rationale data. And effectively, I am just retaining the 4 fields that I mentioned earlier on while I was going through the slides that were important for this app to operate. So the description field, category, subcategory, and the document key, which is actually the ID field in this case. And we get a preview of the results here. You can see straight away that the data is pretty sparse. So although there's a number of IDs that we can see, there's no category, description, or subcategory on this particular tab. And this is fairly common with ticket data from what we'd seen. Often things get created before a huge amount of data gets input into them. So we'll often see them get updated over time with those additional details. So what we're going to do, now we've run that search, we've seen a preview of it, we're going to tell the app what the fields are. So we're going to start by telling it which one represents the ID. In this case, it's the document key. We're then going to tell it what the category is, what the subcategory is. And bear in mind, we don't have to be constrained by picking an actual subcategory or category. Now, the ID and the description, you definitely want to be an ID and a description. But for these 2 fields, you don't have to be so prescriptive. So I've seen some customers, like I mentioned earlier, here put in like service or service owner so that they knew who to kind of produce reports for once they'd gone through the analysis. So don't feel constrained by that. They are just suggestions. And once you've made those selections, you'll get some high-level insights about the data that we have. So in my case, I've got about 20,000 instants in my results. Of those, only about 25% of them actually have a description. which is a fairly small proportion. Depending on how your ticketing systems work, you may see more, you may see less. And we also get a bit of a breakdown by category and subcategory. So here I can see that I've got 8 categories and 96 subcategories. And just to echo one of the points I made earlier, 96 subcategories, although that sounds like quite a large number, actually when you compare it to 20,000 tickets, that's still quite a lot of tickets per subcategory. So just to reiterate my point, often at a subcategory level, the data is still not granular enough to tell you about a recurring problem. The other charts we get here is a bit of a breakdown, just showing you how the tickets are broken out by category and subcategory over on this bubble chart. So we can see most of them don't have a category, which we kind of saw in the raw results above. Then it moves on to apps and services, then computer, etc., etc. Here we have a chart that shows us the number of descriptions in our data set per category. Now, this is important because in the next step of the app, when we start to mine this data for insight, we're actually going to look at the data on a per category level. And like I said, it doesn't matter if your category is actually a category, it could be a business service, it could be a service owner, it could be whatever you want. But the key point here is whatever you've got defined as your category, the thing that we're going to use to spot problems against, you need to have a good amount of descriptions because they're the things that we're going to be looking at to determine whether or not there are recurring problems. And you can see in my data up here with apps and services, we have quite a large amount of descriptions. There's also quite a large amount for the tickets that haven't been assigned a category yet. Then it drops off pretty rapidly. As soon as we hit computer, it's only down to 94 and then much less. And ultimately, most machine learning uses some kind of statistics under the hood. So when we're looking at anything that uses statistics, we might not find anything that is particularly relevant when we're operating at this lower level of tickets. So what we're going to do down here is we're going to pick a cutoff point. And this is going to tell the app which categories to pull forward for the rest of the analysis. So here we've got 8 of them. When we move on to the next section of the app, what we'll see is that has dropped down to just the 3. So the 3 categories that have enough information in them that we will be able to accurately mine them for insights. There's a few options here. I'll start talking about those once I've kicked off the analysis. I've not made any changes, as you can see, but there are a few things we can do. So the first one is to include or exclude numeric values. We've seen a few times tickets, particularly the descriptions, they often contain things like dates. And what we don't want to do is we don't want that date to become an influencing factor in finding the groups. So you could choose to exclude numeric values from the calculation if you want. We then have a couple of sensitivity options. So this one here, the term frequency, is basically saying if there is a term in my description that occurs in more than 35% of my data, it is going to be ignored because it is occurring too frequently to have much significance. So that's the first one. The second sensitivity option is basically saying how many common terms do we need to find in a group to make it valid. So here we're saying as long as there are 2 or more terms that occur across a group, then we're going to treat that group as a valid group. Okay, we could tune that up, we could tune that down. And the idea here is to stop it getting stuck on one particular term. Some people might write things like kind regards at the end of a ticket. when they submit it, for example. And we don't want that type of term to be carried through and to be made a significant thing. And then the other thing we have is cluster using description statistics. So we can calculate some statistics about the description, the length of it, how many words, how many lines, etc. And we can also use those as features when we try and identify groups, because it could be that the structure of the ticket description itself is of importance, and you could choose to use that structure or not. And we can see here that for the computer category, we have 368 tickets, 94 have a description. Now that the analysis has run while I've been talking about those options, you can see that 25 of those incidents have similar descriptions. And of those 25, we found two groups. One with 17 tickets in and one with 8 tickets in. We also have a bit of insight here for those two groups as to what the key terms were. So we can see there's a few things like fonts, Adobe, some data migration that appear to be common with group ID 1, whereas for group ID 2 it seems to be some kind of access information, some kind of asset tag, etc. So we can start to get a bit of a feel for how it's determined those groups. If we want to then start analysing them, so I've picked on group ID 2, I can see here that predominantly it's in the desktop or laptop category. There's a few keywords in here, so these aren't the terms, these are just the individual words themselves. And we can see the raw ticket data below. And here you can see it looks like it's generally related to users who don't have assets assigned to them. Okay. So it appears to be working pretty well. We could have a look at group ID 1 as well. See, this is mostly desktop or laptop tickets. Again, we've got some keywords here. The bit to focus on here, an example, we've got the word office, right? And if we were doing this as a word-based analysis exercise, the word office could relate to a physical office, like it did in the previous group we saw, or it could relate to Microsoft Office, which is why it's quite important to use term-based analysis rather than just word-based analysis for this type of technique. And here you can see we've got a set of tickets. From the description, to me it looks like some kind of laptop or physical device setup. So you can see a bit of a spec. Most of the specs are similar, but they're not all the same. And then a bit of an instruction to say what software packages need to be installed on those devices. Okay. So this looks like it's working pretty well to me. I could save this model now that I've had a look at the groups. And once those models are saved, I could have a look at managing them. So what else might I want to do with this data? So I'm going to pick on that one that I've just trained. In this case, it's the computer category that I've just looked at. This is going to tell me again how many incidents I have within this time range, how many have a description, how many groups exist. So we can see we've got the two groups that we saw previously. And once it has rerun the analysis, we will be able to do a couple of things with our data to maybe help with productionizing some of this analysis, or at least putting it into our own custom reports. So we can see that this is now run. Again, this kind of echoes what we saw before, so the 17 and 8 tickets that we saw in those two groups, as well as the remaining tickets that didn't actually get assigned to a group. And if we pick on one of them, so if we again look at group ID 1, we'll get some similar reports, so we can have a look at the ticket data itself again. But we have a number of other options. So we could edit this group. We could change the name of it. Like I said before, it looked very much like it was some kind of laptop install instructions. I could save that now. And after that, anyone seeing this, instead of seeing group ID 1, they would see laptop install instructions. So make it a bit more descriptive. You're going to have an analyst looking at this data. Hopefully it will be something that they will be able to make sense of a bit more. We could also combine it with some other groups. This analysis isn't perfect. I've often seen situations where you get multiple groups created with very similar ticket data in, and often they just need consolidating. In a similar fashion, sometimes you see rogue data in there, and often that can be excluded by looking at some of the subcategories. So a few things you can do to edit it, and you can as well view the group in search. And this is where it starts to become a bit more practical if you want to start taking some of this analysis and using it yourself. So here we have a whole load of SPL that's been auto-generated through the app. A lot of it is applying the models that we've trained as we've gone through the process of training them. But critically here, this gives you a search. In this case, it's looking for that particular group. So if you have new ticket data coming in, and of course I don't in this particular test instance, but if you see new ticket data coming in related to that group that it manages to find, you could, as you would with any other Splunk search, create an alert, populate a dashboard panel, or create a report. And that alert could, of course, trigger actions, such as some kind of remediation, whether that's as simple as running a script or as complicated as kicking off some kind of phantom playbook. So hopefully that's given you a good overview of the app. And that's it for the demo. So we're about ready to wrap up this tech talk, but before we do, I wanted to share with you some resources that are available to help you continue your journey with Splunk and with machine learning, hopefully. So the first thing to point out is the app itself. So the Smart Ticket Insights app is available on Splunk Base. It does naturally rely on the Machine Learning Toolkit as well, so I'd encourage you to go and download both of those. There is also an accompanying blog post which kind of acts as a how-to guide or as a user guide for the app, so I'd also encourage you to have a read of that. For those who want to learn more, we've got a whole load of sessions coming up at .conf this year, so please go and have a look at the session catalogue for those. There is also going to be a hands-on workshop that we're running in person this year at .conf. So for those of you who are lucky enough to be going in person, please keep an eye out for that. We'll be opening up for registration soon, and that will be an opportunity for you to learn some of the common use cases that we see at Splunk that rely on machine learning and get to understand how you could apply them against your own data. And finally, if you're interested in learning more about machine learning or want to know about different use cases, please have a look at our blog posts. There is a whole load of content there and a whole load of tips and techniques that can help you with your analytics. Also, don't forget that we have an incredible community of Splunk users who are pretty active on our community site. You can search the answers section for machine learning. There's a whole load of useful information there. And within that section, there's also a discussions part for Tech Talks, where you can find some additional resources. And finally, if you have ideas for enhancements to product features or functionality, I'd encourage you to have a look at our Splunk Ideas portal and feel free to submit things. We love to hear from you guys. Thank you for watching, and we look forward to seeing you at future Tech Talks.